Alright, so here we're given this function f sub n of x, and it's equal to this factored form polynomial with a very clear pattern, and the number of factors here would obviously depend on the value of n, right? And now we want to determine whether or not this limit would converge. Now, admittedly, at first glance, this problem might seem kind of strange because we don't know what the derivative function of f sub n of x is, right? I mean, if we knew that, if we knew what that was, right, then this problem wouldn't be that bad as given. However, that is the main obstacle. What is the derivative function of f sub n of x, right? Well, I mean, you could try using product rule on this large product, but the main problem isn't even that there might be a lot of factors and therefore it would be very tedious. The main problem is that this n is not fixed. It's a variable positive integer. So therefore, product rule wouldn't even give you a neat closed form expression for you to work with. So we're going to have to resort to other methods. Just think about it. The reason that this question is kind of annoying is because, well, this is a product, and there's no such thing as a differentiation rule where you just take the derivative of each individual factor. That does not exist as a derivative rule, right? However, if we can somehow express this f sub n of x as a sum of, well, different functions, then you can indeed differentiate term by term. That is a valid rule. So let me ask you this. Is there a particular operation we can do to both sides of this equation so as to transform this right-hand side into a convenient sum? Take a moment to think about it. Well, there is one very famous tool for this, and that's the logarithm. I'm just going to choose the natural logarithm for our sake, right? So for natural logarithm, if you have two numbers a, b, right, multiplied, and then use that as the input, then assuming that a and b are both positive, you can write this as natural log of a plus natural log of b, right? This is a very famous logarithm rule. And indeed, we can try applying the natural logarithm on both sides of this equation. So that would become natural log of f sub n of x, and this is equal to, well, the natural logarithm of this entire product. But then using this rule, we can split it up as natural log of 1 minus x plus natural log of 2 minus x, and then plus all the way to natural log of n minus x, right? And by the way, this is indeed valid to take the natural logarithm of both sides, because notice that we're only interested when x is equal to 0, and substituting 0 into this expression, well, each individual factor is going to be positive, so you don't have to worry about having negative values inside your logarithm. Anyways, moving on. So right now, right, as you can see, we have this expression, and we can use implicit differentiation with respect to x on both sides, right? So differentiating this, we get 1 over f sub n of x, and then using chain rule, f prime, and then sub n of x, and then we differentiate this side, and we can just term by term differentiate. So we get negative 1 over 1 minus x, minus 1 over 2 minus x, and then plus, not plus, but minus all the way to 1 over n minus x, right? So now, notice what we have here. We can finally, well, we're interested when x is equal to 0, so let's plug in x equal to 0 for this equation. So then we would get 1 over f sub n of 0 times f prime sub n of, you get the point, right? I'm just going to plug it in. Right, so I'm finally done. And now, what is the value of f sub n of 0? Well, let's scroll up and take a look. So over here, if we plug in x equal to 0, then f sub n of 0 is equal to n factorial. So therefore, right, let's just multiply n factorial from here to here. So f prime sub n of 0 is equal to negative n factorial, and then times this sum, correct? Right. And now, let's revisit our original question. We want to see whether or not the limit of this would converge. So precisely, look at this. We want to take n to be infinity for this entire expression and see if it converges. Well, what happens? This n factorial would obviously blow up, right? However, what about this? Well, this is the famous harmonic series, right? And famously, this would also diverge to infinity. So actually, this entire expression would diverge to negative infinity because of this negative sign, right? Now, in case you were confused on what I meant by the harmonic series for this sum, well, essentially, the harmonic series, they are defined by h sub n is equal to, well, 1 over 1 plus all the way to 1 over n. Or you can write it as a summation notation, right? So this is also another way to write the harmonic series, and it actually turns out that the limit as n approaches infinity for h sub n, this would actually go to infinity, which is actually kind of strange because you can see that the terms here would obviously decrease, right? As n becomes larger and larger, this last term would actually shoot towards 0. So it's actually kind of interesting why this would still diverge to infinity. Anyways, that could be a topic for some time else. So over here, we have our final answer. It diverges to negative infinity. So therefore, right, our answer is no. This limit does not converge. And that is our final answer. So there we have it. We have our answer, but then notice some problem solving strategies. Well, over here, we notice that we can't really differentiate a product conveniently. So try to always think of some other tool that you can use to convert some expression into a more manageable expression. In this case, you don't want a product, you want a sum. So think about some sort of operation to convert products to sum. Famously, that's the job of a natural logarithm, or any logarithm really. But anyways, I really hope you enjoyed this video, and I really hope you found it interesting. If you did, then please consider dropping a like and subscribing. Thank you very much. Bye!